Good morning or good afternoon, whenever you're watching this. I am going to try and take you through as much of this this final as possible. The first thing we do, obviously, is we're going to have. Whoops! Let's undo that. That was bad. Let's create a circle. That should be good enough. All right. Then we're going to talk about the unit circle. And I'll just start putting lines across it. There's my diameter. And then I'll put one here and we'll call this 30 degrees. So there are a bunch of things. You're going to label your unit circle. And here we go. So this is 0 degrees here, or 0 radians, or 2 pi radians, 360 degrees. And this has coordinates, right? And we know that it's to get to this point right here, and that's what these coordinates are telling us. To get to that point right there, we've gone over 1 and up 0, right? We also know, because we've written this down, that this is the y value is the cosine value, and the y coordinate is the sine value. So x is cosine, y is sine. So if we give you, give me the 6 trig functions of 2 pi, you can tell me that the sine is 0, cosine is 1, and the tangent, therefore, would be sine over cosine, which would be 0 over 1, and that tangent would be 0. And then the inverses of this. So if this is 0 over 1, which is 0, the cosecant would indeed be undefined, because you can't have 0 as a denominator. It would be 1 over 0, right? Because this 0 is just basically 0 over 1. This cosine, the secant, which is the inverse of that, would still be 1, because this is a fraction, 1 over 1, which is 1. And therefore the secant would be 1. The tangent, just like the sine, would be the cotangent, which is just like the sine, it would be 1 over 0. And that doesn't exist, right? We know that that doesn't exist, so that too would be undefined. Right? And so let's go ahead and look at some trig functions of something else. And I'm going to go ahead and use this guy over here. Let me get rid of this. Just give me a second. If this is pi over 3, right, or pi over 6, which is 30 degrees. Let's go back way over here. This is 7 pi over 6. Or this is, 30 degrees past 180, or 210 degrees. So we're going to look at sine, cosine, tangent, cotangent, secant, and cosecant. And we're going to just call it 7 pi over 6. Let's say 7 pi over 6. I hope I left myself enough room. Anyway, so you know that over here, your coordinate pair would be, let's see, coordinate pair would be over root 3 over 2, and then up, go back to this, it would be up 1/2, right? And you'll use your unit circle for this. Shouldn't be difficult. But way back over here at 210, your coordinate pair is a little bit different. And the only thing that changes are the signs, right? So instead of just root 3 over 2, it's negative root 3 over 2. And then it would be negative 1/2, right? Because both the sine and cosine functions down here are negative because we've gone backwards root 3 over 2 and down 1/2. Right, so let's go ahead and write this, and this is probably going to be in my way, so I'm going to get rid of it. Sorry about that. Here we go. So the sine of 210, or 7 pi over 6, would be, and I'm going to use a brighter color so you can see it, negative 1/2. Right? And then this would be negative root 3 over 2. Now we have a problem, right? So we have tangent, which would be positive. It's basically negative 1/2 divided by negative root 3 over 2. And of course, I'm going to do the math way down here. When you divide, you would end up with 1 over root 3. But we can't have 1 over root 3, so we're going to say it's root 3 over 3, right? So root 3 over 3. And we're going to keep this here so we can use it for cotangent, because we won't have to simplify our radical denominator over here at cotangent because we won't have a radical denominator. This, we just simply flip it upside down, so we have negative 2 here. This one we have to undo the radical denominator, because this would be 2 over root 3. And to do this, we just multiply both the numerator and denominator by root 3, so it's negative 2 root 3 over 3. And last but certainly not least, we will have negative root 3 over 2 divided by negative 1/2 for cotangent, and that would just simplify to root 3. All right, so that's using our unit circle to write out our 6 trigonometric functions for those 10 problems, and 4 of them are in degrees, and the other 6, pardon me, are in radian mode. And sometimes you go negative, so you have to go backward, right? So if you go this way around the circle, that's the positive direction. But if you go this way around the circle, this is the negative direction. All right, so I'm going to move on. Let's see if I can capture all of this. I can. Get rid of it. Move on to the next section. The next section, in and of itself, don't do that yet. Sure, why not? Let's just work with simple SOHCAHTOA. And so if I have a triangle, let's see if I can build a triangle. Let's use lines. We're going to have right triangle. There it is. And let's give ourselves, let's say this is 10. And we're given an angle of 30 degrees. 30 degrees. The reason I use 30 is it's super easy. And it says, let's find the length of this side. And so the easy part of this is we know that what the sine of 30 degrees is. But the way to solve a problem like this is if we're looking for this side and we've been given an angle, and this is that building problem that you'll be solving. It's like any problem that you're solving. If you know, this was launched at 10 meters a second, an angle of 30 degrees. I don't know why I said 30. This should be 60. Woo! Because up there should be the 30. 60 degrees. I don't have time to go back. It takes too long to make these videos. All right, let's say 60. All right, so we say that the sine, because we're looking at opposite and adjacent, right? So we say that the sine of 60 degrees is equal to some number over 10, right? And the best part about this is we're going to have calculators, and make sure your calculator is in degree mode, which is what I'm doing right now. You don't know that, but I am in degree mode. So I'm ready to go with my calculator. I don't have one that I can display on the screen, but just to solve for x, all I have to do is get rid of this 10 here, right? So I'm going to go ahead and multiply both sides by 10. So I have 10 sine 60 equals x. And all I have to do is turn on my calculator, hit 10 sine 60, and enter. And I get a value of about, I guess I could say about 8.7. Right? And that's how you solve that. And those couple of those will be multiple choice. It should be nice and easy. There will be other problems. There'll be problems where, let's see how far I can go back doing this. There'll be other problems with that triangle. It's probably going to stop me pretty soon. Yep. Okay, so let's see if I can get rid of the angle. That's good enough. And I'll do the same thing here. All right, so there'll be other problems on this test where you're given, let's call it, we'll give you theta here, and we'll give you a value down here of, I don't know, 6. And yeah. And it's going to say, give me the value of theta, right? It says, well, what would the value of theta be? And we would say, well, what would the value of theta be? We'd say, okay, well, let's find the cosine of theta. is going to be equal to 6 over 10, because now we have two sides and a ratio. So it would say, what is cosine theta? And you'd say, well, it's 6 over 10. And that's really what it is. The question would be, find this particular ratio. What if it said, hey, find sine of theta? Well, then you don't have this side here. You'd have to find it. You'd have to use Pythagorean theorem. And when you use the Pythagorean theorem, this ends up being 8. And so the sine of theta would be 8 over 10. It might be simplified to 4/5. Sometimes you'll have a square root, because what you'll do is you'll use Pythagoras. That's what I used here. 10 squared equals 6 squared plus that unknown side squared, so I call it x squared. 10 squared minus 6 squared equals x squared. And then I would do 100 minus 36, which is 100 minus 36 equals x squared, which is 64 equals x squared. And we take the square root of both sides, and we get 8 equals x. And of course, you don't have to worry about the positive or negative values, because we can't have negative length or negative distance on a triangle. All right, that's a physics thing, and we'll get to that when you take physics, or if you take physics. Let's move on. Those are my triangles. So I'm going to move on and do just a little bit of what we were talking about before. I'm going to do some simplifying of fractions, but I'm going to do simplifying of fractions with trig functions. Right, this is the last part. I'm going to do one or two of these. I'm going to do one where you're basically simplifying a fraction, but also it's a complex fraction. But then I'm going to also do one like we did in class of proving an identity. So simplifying a fraction, simple idea. Let's say I have cosine theta times secant theta, all divided by the tangent of theta, right? And so what I want to do is I could invariably turn everything into sine and cosine. So at first I'm going to do that. Let's go ahead and do that. Let's say I could simplify this pretty easily. I already know it in my head, but let's go ahead and do that. Let's leave this as cosine, because it's already in sine or cosine form. Let's do secant in sine or cosine form, which is 1. Secant is 1 over cosine. And then on the bottom, let's go ahead and do it sine over cosine. And theta. All right, so let's go ahead and simplify the top first. Cosine times 1 is cosine. This is like a fraction over 1. I don't know why I have to write this anymore. You should already understand that. These two things give me cosine over cosine, which equals 1. And we still have sine over cosine. I could leave it as 1 over sine over cosine. If you already know that you have tangent on the bottom, you could say what's 1 over tangent and be finished with this problem, and that's okay. I'm going to continue because this next skill is important. We have 1 in the numerator, and we're going to multiply by the reciprocal of what's the fraction underneath, and the reciprocal of the fraction underneath is cosine over sine. And that, my friends, is cosine over sine, which is cotangent. Once you got to this 1, once this simplified to 1, you probably saw that it was 1 over tangent, which is cotangent. But for purposes of the rest of the test, using this idea of converting to sine and cosine is very important, especially when you're simplifying complex fractions. So those are the big ideas for that type of problem. There's going to be another type of problem, and hopefully I can make this work out. My next problem says, just scrolling now on the test so I can get to something I can work on. This is the one we did in class, so let's go ahead and look at this. A little reminder, let's go ahead and do the first one that was super simple. It was 1 plus the cosine of x all over the sine of x, because this is an important skill to have, equals cosecant x times, plus cotangent of x. And we get nervous, we only see one of these things here. It's not squared here. If this were squared, we'd have a Pythagorean identity. We're not going to use Pythagorean identities for this problem. What we're going to do is take this complex fraction over here. And why is it complex? Because we have some addition on the top. We can split this into 2 simpler fractions. And that's all we're going to do. So we're going to leave this equal sign here. And then we're going to split this into 2 separate, easier fractions to understand. That's 1 over sine x. And we're going to add it to cosine over sine. Well, this is a skill you need to understand in mathematics. You can always do this. A sum over some denominator is the same thing as the sum of the first part over that denominator and the second part over that denominator. Got it? Most of you already see this because you already understand the functions. There they are. 1 over sine obviously is cosecant. And then cosine over sine obviously is cotangent. So we were able to verify. The last thing I'm going to do for this piece, which is almost the last thing I'm going to do for this video, is, do I want to do this? Sure. All right, let's go ahead and do it. Let's change the color so we can see it, so we know it's a different problem. We have secant I messed up. Let's do cosecant of x over sine x minus cotangent over tangent. Sound good? Okay, so cosecant is 1 over sine. Oh, this is supposed to be equal to 1. Sorry about that. Here we go. 1 over sine all over sine. And then we're going to subtract from that cosine over sine. And then sine over cosine. Now we're going to simplify these complex fractions. Let's go ahead and do that work. And I'm going to move it way up here. Now, divide by the reciprocal of this. This would end up being 1 over sine. This is the numerator. This would be the reciprocal of the denominator, 1 over sine. Okay, well, that is that would end up being 1 over sine squared. Let's leave that there for now. I'm going to simplify this guy here. Sine, sorry, my fault. I have cosine over sine, and then the reciprocal of this guy right here. The reciprocal of this guy right here is also cosine over sine. It's not squared yet. And that is equal to, so this is the numerator, this will be the denominator, this will be what we're subtracting from it, sorry. I'm confusing myself. This would be cosine squared over sine squared. And I think you now see where it's leading. So we're going to subtract these two things from each other. We're going to have 1 over sine squared minus cosine squared over sine squared. We do that math, we get 1 minus cosine squared over sine squared. We see right here that this guy, this wonderful guy right here, is a Pythagorean identity. 1 minus cosine squared is equal to sine squared. Well, now we have sine squared over sine squared, right? We've replaced it with sine squared. That does indeed equal 1. All right? And let me check to see if there's anything else that I need to do to make sure you guys are ready. The only other thing will be limits, and I will go through those one more time for you guys just to make sure you understand limits and derivatives. I'll make one more video that goes along with this. Thanks for your time. The next video will come up this afternoon.